just so you believe me, you know what this is? Geiger counter, right? It's going to measure those particles being emitted. They're not very energetic for uranium. Look how quickly it falls off. And it's because the particles are being stopped by the air between here and here. So hardly any of it goes more than a foot or two. But not all particle emitting elements are so non-invasive in their radiation. Some stuff is very, very dangerous, and you have to be behind many feet of cement and lead to be protected. So this is one example. They made this stuff up to into the 1970s, actually, but it was very popular in the 30s and 40s. So I used to carry around a bowl. It was my wife's grandmother's. That was the only piece I had. So one Sunday or Saturday morning, I guess, I was in my ground state, and my wife says, let's go to an antique store. Dig around Chipchewani or something like that. So I didn't want to go. I was happy in my ground state. But, once in a while, you just have to bite the bullet, go along with what the wife says to keep the peace, right? So I went. I said, look, if I'm going, I'm going to be on a mission here. I want to find some more pieces of radioactive stuff that are a little more convenient to carry around. So I told her I'm going to take my Geiger counter with me. So we got to a store, and we're walking around, and there's just shit everywhere. I'm kind of looking at the stuff and saying, this is a possibility here. I'm not going to know until I get my Geiger counter in there. I said, but this looks like it could be good stuff, and this and this. So I finally went up to the people at the front desk where you pay for everything. I said, I'd like to bring my Geiger counter in here and check some of your dishes for radioactivity. And they about hit the floor on that. They had no idea what I was talking about. They had no idea Fiesta ware and some of the stuff they had in there was radioactive. But they were very curious. So they let me come in. Before long, all the store employees are behind me, watching everything I'm scanning. And I picked up stuff. In fact, I got this there. And this was another dish. This is another form of glass. It's called depression glass. You ever hear of it? Very cheap, made during the Depression. And the green color is due to, guess what? Uranium. But there's not as much in here. So it's much, remember this one? Just not as much color. So actually I did pretty good. I didn't mind being out of my ground state for most of the day, because I ended up with a couple prizes. You remember Rutherford, when he did that experiment where he was sending bullets through gold foil? Remember that? And those bullets would get diverted at different angles. And it was that experiment that allowed him to determine that most of the mass and positive charge of the atom is in this very tiny region called the nucleus. Do you remember that from a few weeks ago? What he used was something like this. A radioactive element is putting out bullets. What you're detecting here, is the decomposition of uranium. Because it's an unstable element, and it decomposes to thorium plus a helium nucleus. There's your bullet. The thorium stays behind. Okay, but what comes out with high energy is the bullet. And that's what Rutherford used as a bullet. Something radioactive that would shoot bullets out. So he just had it set up to direct this beam toward the gold foil. And then each bullet, when it hit that detector, which was that zinc sulfide around it, it gave a little spark of light that you could see. Okay, so that was his experiment. And these were the bullets. Came from something like this. These are low energy bullets. There's others, much, much higher energy bullets, and you don't want to be near this stuff. Certain types of plutonium, radium, there's a number of them. Uranium is it's a non-toxic metal, and its radioactivity is very, very weak. So I guess that's why families could eat off of it for whole generations. And they ended up okay. Although you guys are the offspring of some of those families, I'm beginning to believe I see a little bit of something going on here. You know, mutations skip a generation now and then. Okay, now, you know what? You all are going to see much better if you can center yourself up here. So from the back, you can just leave your stuff, but get closer. Here, you're going to have to come up here and get one of these. These are these gratings I was telling you about, and I'll show you how to use them. They look like old 35 millimeter, I don't know, whatever they're called, slides. So just hold them by the edge, that's all. So everybody take one. If you center yourself more in here, you're going to see a lot better. I do want these back, by the way. So one other thing I wanted to show you, I have up here a mineral. It's called, I don't remember what it's called. It's got a card in here. I only use it once a semester. Altonite. And the reason I was very interested in this mineral is it's a crystalline mineral that has uranium in it. Plus, it is a very strong fluorescer. So if you shine ultraviolet light on it, it fluoresces, in this case, a blue-green color. Now, you guys have seen this before, right? They shine the ultraviolet light on stones, certain stones, and they shine the UV on them, and all of a sudden they turn red, or yellow, or green, or something, depending on the substance. Some of them don't do anything because they don't fluoresce. This particular mineral, it fluoresces because what you're doing is you're coming in here with ultraviolet. So this is your source of energy. You're kicking an electron from its lowest energy level to a much higher energy level. And it turns out for that particular mineral, it's very favorable for that electron. Instead of collapsing all at one time back to this, it does it in stages. And the first stage in going from 4 to 3 emits a yellow-green light. That's fluorescence. That's what makes the minerals glow. Certain colors under UV light. It's all because you're inputting energy to get the electron to a higher energy level. And again, all it wants to do is get back down. But it can do it one at a time, or it can do it in stages. In this case, it takes one small blip before it falls down to here. This is what emits that fluorescent color. So I have here a source of ultraviolet, which I'll turn on. And I'll do my best so you guys can see this. I'll turn the light out in a minute. You want to put that monitor down back there? Thank you. So can you see that? You have to stand up. I can only tilt it so far. But you see how it's glowing blue-green, or yellow-green, right? So again, the ultraviolet light is kicking an electron to a higher energy level that then cascades back down. And the first cascade step is the part that emits this fluorescent yellow-green. So now on these slides, you're going to hold them initially so the long part is horizontal with the ground. Okay, like that. You put it right up to your eye. And so what we're going to be looking at, first we're going to start with this thing. And then we'll go on to some gas tubes. But as you look into it, this is going to break the light up into a spectrum. And you'll see the spectrum off to the right or off to the left. It produces it on each side. Okay, so which side you prefer, I don't care. The red will always be furthest out up to the blue. And you'll see that. You can look at it right now. Try it with that. Can you see it? So the one on the top is white light. So that should produce for you an entire spectrum. Right? Like Newton saw. And then the other diodes below it are all made to emit at a certain wavelength. And so you'll see those at different positions, won't you? Below the white one, which is spread out all the wavelengths, and then you'll see these various colors at different lengths, distances along that. Is that what you see? Mm-hmm. Okay, so that'll help set things up. Now the first gas that we're going to look at here, what I have here, are called gas discharge tubes. So this tube has hydrogen in it, and we're going to pass 5,000 volts through it. And that's going to make the gas glow. And so here's your little narrow slit like Fraunhofer used to create the lines. And so you're going to look at this thing, and what you're going to see with hydrogen is this. The electric current is going to kick electrons up to the higher energy levels, and they're going to cascade back down. If they cascade from 2 energy level 2 to 1, it produces a deep red line called hydrogen alpha. If it goes from 3 to 1, that is called hydrogen beta, and it's a turquoise line. Remember, these are the fingerprints, the emission lines that this element produces. 4 is going to be hydrogen gamma, which is blue, and violet will be coming from energy level 5, jumping down to energy level 1. Okay? Can everybody see? You see the red line, the turquoise, the blue? If you have good eyesight, and all of you are pretty young, as you get older, you lose your violet vision because of age. I can't see it, but many of you probably can see it. So everybody sees it okay?
Yep.
Huh?
Yep.
Okay. Because I think before I've had students, after I've done everything and been done, they come up here and say, well, I never could see anything. Why didn't you tell me when I was asking you? You know, so I'm not going to reset everything up at that point. You know, but they wouldn't speak up. So they missed out on everything because they didn't know quite how to look through it. This one is helium. A little more complex, isn't it? Because here we have 2 electrons that can go to different energy levels. So the spectrum starts to get a little more complicated. And you'll see that as we go to more complex elements. Things are noisy, aren't they? At high voltage, it makes it vibrate in there. I don't know, it's always done that. You guys on the end see this okay?
Yeah.
Okay. I always like to look at them too, you know. So what do you see? So you see yellow, green, and almost kind of a violet-y, isn't it?
Mm-hmm.
Do you notice anything funny about that yellow line? Anything different from compared to the other 2?
It's not as bright.
You know, it's not as bright, but there's something else about it. Anybody see it? There's 2 of them. There's 2 very closely spaced lines. This is Mercury. So that combination of the violet, the green, and the yellow in these fluorescent tubes is what gives us the white light. That's why we use fluorescent bulbs, and every one of them has a tiny droplet of mercury in it. Since it's a liquid, there's a few of those atoms that are in the vapor state because it's a liquid, and that's what's being excited in these lamps. That's what's being excited in this one, are those vaporized mercury atoms. And this is the spectrum that mercury produces. Some of these do not produce nice, clean, obvious fingerprints. This one's a toughie if you're further away. I can barely see it from over here. But if you're closer up, you're going to be able to see some faint lines, aren't you? Mm-hmm. So this one's not too exciting. It turns out this is xenon. second to the last. The last one, I saved the best till the end. So now that you've done this enough, you should be able to tell me what this element is. What do you see? Even from a distance, you should see two lines, right? An orange and a green. And there seems to be a clutter of lines out in the violet part, perhaps very close together. Anybody want to tell me what this element is? I'll give you a hint. Superman came from there.
Krypton.
Krypton, the gas krypton. Now, krypton actually exists, but kryptonite does not exist.
That's good to know.
Yeah. Yes, it's very good to know. I'll ponder going home tonight.
Yeah.
Okay, one more of these. This is the best of all. You might actually guess what it is.
Oh my.
Now, that's pretty cool, isn't it? This has lots of lines, as you can see, across all parts of the spectrum, which makes this a very, very useful gas for advertising. So what is it? Neon. Okay, so if all the light together coming out gives you this orange color. But if you want your neon light to be just yellow or red or green or orange, you use filtered light, don't you? Filtered glass. It will remove the lines you want it to remove and allow the ones